This is the Conservation of Energy Lab. In this lab, we're going to look at all these questions you might have. Is Mrs. Hedden telling the truth? Does energy really swap places from one form to another? Does total mechanical energy really stay the same? Does kinetic energy really change as you change height? Does potential energy really change as you change height? So this can all be summed up as the purpose of this lab is to explore the relationship between mechanical energy, potential energy, and kinetic energy. Because we're exploring the relationship between three different things, you're going to have three different independent variables: mechanical, potential, and kinetic energy. What you have in common with all of those is going to be time. So time is your independent variable, and the three energies are your dependent variables. So you're going to go out and you're going to record a marble going up and down a roller coaster. You're going to put that recording on your desktop, and immediately you're going to save it to your Z drive. And then I'm going to open up Tracker. I get Tracker open, I'm going to import the video. I'm going to zoom to fit it, and I'm going to play it once in here and find out right when I let go. So I'm just letting go right there. So I'm going to make that my starting point. Let it play. Let the marble go up and down. Stop. Maybe make a couple more steps. And that's going to be my end point. You want to be sure and end this before it gets into that little dip right there. So let's see right here. You don't want it in there. You want the marble to still be on the track. After I've selected the area of interest, I'm going to go ahead and track my marble, making a new point mass. So I'm going to create a new point mass, and I'm going to start tracking it by hitting Shift and placing my marker on it. It doesn't move too fast at the beginning, but it will. Okay, I've got all my tracks made, and now I need to copy some data over. Oh, wait a minute. Before I copy data over, I've got to insert an axes and the correct calibration. When you go to insert the axes, having all the tracks on there causes some problems sometimes. So I'm going to go up to the trail button and hit no trails. I'm going to reset this so I know where my thing is starting, because I want my starting point, kind of, sort of, to be where my axis is. So let me put the axis in. And I want to line up my Y with that. But I don't want my x-axis lined up with that. So what I'm going to do is let the video play through. And I'm going to pull down my x-axis so that the last point it's at the 0, is right on the axis. So I've got the x-axis lined up with my end point, and the y-axis lined up with my starting point. Pretty close. There we go. So now I've got my axes in place. Let me play it through one more time, make sure I'm still good. Yep, looks good. So my axes in. So once you put your axes in, it's there. I can take it off now. It's still there. Next thing I have to do is calibrate. There's a lot of ways to calibrate, and if I'd had a meter stick in there, I could use the meter stick, but I don't have a meter stick in here. I do have markings on the roller coaster. I want to use the place where it's as straight as possible, not where it's curved, because the curve is not going to be, I don't have a curved meter stick. So I'm going to go up here to the calibration. I'm going to grab a calibration stick. Okay, I'm going to have to zoom back out to find it. Oh, there it is. I want it over by the straightest part of my track. I'm going to zoom back in. And so the straightest part is probably between this point and this point. Okay, from here to here. And each of these big marks are 5 centimeters, so between one big mark and a second big mark, I've got 10 centimeters there. I'm going to go up here, and I'm going to change that to a 0.1. Why 0.1? Because 10 centimeters is 0.1 meters. Now, there's a hint. If I just hit enter on the keyboard, sometimes it takes, sometimes it didn't. Of course, it worked perfectly this time. A surefire way to make sure it always takes is to hit 0.1 and hit tab, and it goes to the next point, and then I know for sure it's good. So then I'm going to go ahead and hit enter because I'm fine. So I've got my calibration made. Zoom back out. I can take the calibration stick off again, just like the axes. Once it's there, you're good. And then the next thing we're going to do is copy the time, the Y position, and the velocity. There's lots of ways to do that, but the easiest way is to go over here to this table. Sorry, to this table. So I clicked on the table button, and I want to click time. Oh, I don't click time because it'll automatically carry it over. I don't want X, so I'm going to take the X off. I do want Y, so I'm going to leave that in. I just want velocity, so I'm going to click on velocity. So I've got the Y position, how high it is, and the regular velocity. Notice again, the velocity I chose is just V, not Vx, not Vy, just plain old V. So I've got that. I'm going to hit close. Notice they automatically appeared over here. I'm going to highlight it all, and there's a lot of data there. I'm going to copy it, and I want it full precision. Then I'm going to open up graphical analysis as soon as I find it. There it is. I'm going to click on my first thing, and I'm going to paste all this. Make my data table a little bit bigger so I can see it. The first column we can see is T, so I'm going to relabel this right away as time. Short name is T, units are seconds. The next one is my Y position, so I'm going to label it right away so I don't forget. Short name Y, units, meters. The next column, you can see here it says V, so it's my velocity, so I'm going to label it right away so I don't forget. Units are meters per second. Once I get them labeled, I can go ahead and delete these first three lines. Notice that we've got time 0, and we don't have a velocity there. That's because we don't get a velocity until we have 2 Y positions. Well, so I'm just going to delete the first 2. Done. Now I'm going to have to make some new calculated columns in order to find kinetic energy and potential energy. New calculated columns, I go to data, new calculated column. I'm going to call this one kinetic energy. Short name, KE. Units, of course, are joules. And then I have to put an expression. Kinetic energy is 1/2 mass times velocity. But because we've got a rolling marble, we have to use a special expression. So instead of using 1/2 for this lab and this lab only, we're going to put in 0.7 and then times, and then the mass, and you'll have the mass, it'll be given to you. It's 0.028 kilograms, and then you're going to take it times the velocity squared. Well, it knows what the velocity is, but you've got to tell it that it knows it. So you go over here to variables, and you pick velocity, and then you can use caret 2 for velocity squared. Done. And notice it put it in right away. Now I've got to get another one. Data, new calculated column. I'm going to put in potential energy. The expression for potential energy is the mass, which you'll be given, 0.028, times gravity. I want you to use 9.8, not 10, but 9.8. And then you're going to put in the height. And again, the computer knows the height. It's the Y position, but you've got to tell it that it knows it. So we're going to go over here, and we're going to pick up Y position, and we'll be done. And now the last one, we're going to go to data, new calculated column, and we're going to put in the mechanical energy. The equation for mechanical energy is potential plus kinetic. So again, it knows it, but you've got to tell it. So you've got to go to variables. You're going to pick up kinetic energy and plus, and you're going to pick up variables and potential energy, and you're done. And now you've got them all there. I'm going to make this table smaller. We're not seeing anything though, so I'm going to go over here, click on the graph options and axes options, and I do not want the Y position. I do want mechanical, potential, and kinetic. And I'll hit done, and it'll be there. If, obviously I didn't hit done because I want you to see what your data looks like. If you're getting something like this where it's down in the mud, you can have it auto scale by pushing that. Okay, you're going to be printing out the tracks. Well, you can look at the lab tomorrow and find out what you're printing out and how you're going to analyze it. So you'll be looking at a bunch of things, and that's the end of this video. Thank you very much for your time.